Right. And let me minimize that. Let me share my screen. All right. Let me minimize this. All right. Can everybody see my screen?
Yep.
Excellent. Okay, let's see. We are starting our 11th week, and so this week we're going to be chatting about MongoDB. Let's see where we've been, where we are, and where we're going. Right. So we just finished week number 10, where we discussed transactions and indexing as ways to deal with concerns on performance, as well as concurrency, where you have multiple users trying to use the same database, and we want to make sure that folks are not trampling over each other, and indexing for improving the retrieval of data, performance and retrieval of data. You also, I believe, should have taken the ORM exam, a quiz last Friday. So this week we're going to be focusing on MongoDB. So MongoDB is one of many different alternative databases other than relational databases, right? So 90% of this course is on relational databases, right? Creating a object model, represented as a UML class diagram, and then various strategies on how to convert that into a relational model that we can be implemented in any relational database. In particular, we'll be spending a lot of time with MySQL, but certainly these strategies can be applied to any relational database. But we do want to take some time to consider other alternative databases that don't use SQL at all and are not built around the relational model, right? With the fact that are fundamentally different because we store completely different types of data and are trying to solve an entirely different set of challenges. So we're going to be spending some time this week on using MongoDB as one of many, and there's a plethora of non-relational databases out there that are becoming more and more relevant today as we are creating huge amounts of unstructured data, and we want to be able to store that and do queries and do retrieval and whatnot. So we'll talk about MongoDB today, and we'll talk about Mongoose as a library for interacting with Mongo, and then we'll also talk about Firebase. This will probably spill over until next Tuesday. We probably won't finish this week. So yeah. So next week we should be starting up working on our project, and so you should be all working towards the first project assignment, which is coming up with a design and coming up with an implementation of that UML class diagram. So you come up with some UML class diagram, and then the relational database that goes along with that UML class diagram. It's going to be a first draft. It doesn't have to be the final version of your database. Certainly, there's as you progress for the next 2-3 weeks, right? You might find yourself that you'll need maybe an additional table, or you don't really need this other table, or maybe you need a couple more foreign keys and primary keys. As you start working and implementing it, you'll find that you might need to modify, and that's perfectly fine, right? So this first P1 is intended to have just give us a first draft of what the UML class diagram might look like, and what the relational database also goes along with that class diagram. But again, feel free to modify it as you learn more about the implementation. So yeah, that's P1, and that's due next Tuesday, I believe. Yeah. So right. So let's focus on today's and this week's topic. We'll talk about non-relational databases, in particular MongoDB. Let's see. Any questions before we get started? All right. So if there are no questions, we're going to go through some of these slides that are here in week 11. And so let's get started first with MongoDB.
There's a question in the chat.
Oh, yes. Let's see. The chat says, currently we can't access document 10th assignment. When is it? Oh, yeah. The assignment number 10 is going to be available later today. I'm still tweaking it a little bit. Although I'm gonna start demonstrating it here for you. So the work that we're going to be doing here live is directly taken from the assignments. Yeah, we made available later today. Yeah. Okay. So let's talk about MongoDB. So MongoDB is one of many databases that have fallen under the umbrella of NoSQL or non-relational databases, and so even though it sounds like there's two buckets, right? The relational databases and the non-relational databases, it only looks that way because relational databases have been so dominant, right, in industry for so long that most of us don't consider anything else. But in parallel, there have been many different types of problems that have required databases that where the relational the way of thinking about the data in as relationships between data sets is not applicable. Okay, there are many different types of other problems out there that relational databases just basically don't cut it, right? In particular, there are real-time databases where you might have data that is being generated in real time that you might be measuring some phenomenon in your process as you are building something, either something chemical or whatnot, and you're measuring pressure, you're measuring temperature, you're measuring speed, you're measuring all sorts of variables that you need to keep track of in real time, and those generates huge amounts of data in a small amount of window of time, and usually you want to take a look at that data within this window of time that might be seconds, might be minutes, might be hours, at most a day. Okay, but this is data that comes into the window of interest, right? So you can analyze it and you can find trends and averages, and you can compare data, and you can do queries and whatnot, right? But then they fall off out of the window and then they're lost forever, right? You don't keep track of them. Although you might maintain some sample data, right? That is representative of what it is that you want to capture and analyze, right? But in general, it might be some sign or some we'll have some waveform, whatnot, that you want to analyze in real time, right? You want to see, maybe identify relationships between the amount of oxygen and carbon and some reaction that is happening in real time. And you want to be able to query it and make decisions on trends and averages and whatnot. Okay, and so in that sense, relational databases just basically doesn't have anything to do in there, right? Because generally relational databases are meant for storing things for the long run, right? And that have a very well structured data set and that are the schema is very well defined, and it's unlikely to change over time, right? That the structure, if it changes very slowly, right? That you designed it at first, you did the normalization, the relationships, right? And you start, once you've designed it, the changes after that implementation changes very slowly over time. Whereas you might have other problems that you're trying to represent data that doesn't have a very well defined schema, right? Or it is not very well structured, right? That is changing very frequently over time, or that you're trying to discover what the schema is, right? And so problems such as, whenever you pick up your phone and you wave it around, right, you create a stream of data that somebody is capturing, and they're trying to maybe relate that data with other data, right, based on my where I have been geographically, what my preferences are in Netflix, what articles I've liked on Twitter, right, or different things, and then they're trying to analyze all sorts of streams of data and trying to identify trends from a huge amount of set of unrelated, seemingly unrelated pieces of information that we're trying to discover what the structure of that data is, and it's changing and over time, right? So that again, in that sense, relational databases again doesn't have anything to do there, and increasingly this has been the case, as folks are using more and more connected devices and are interacting on the internet, on the web, and are producing these huge amounts of data by consuming content on Netflix and Amazon and Apple TV, and and interacting on Twitter, blah blah blah. They're generating gobbles of information that that folks are trying to make sense out of it, right? And usually it entails throwing some very powerful algorithms that identify these patterns, identify these relationships, and mine the data for information, for structure, right? And once we do identify the structures, then we can come in and perhaps use relational databases to capture that information once we identify what the structure is. So anyway, there's tons of databases out there. MongoDB is just one of them, but certainly there's many others that I encourage you to explore and read up on. Right, there's Cassandra, CouchDB, Redis, DynamoDB, there's Firebase. I mean, there's tons of these other databases out there that I really encourage you just for your own growth, in the industry and academically, to look up all these other databases that are out there. So we're going to be focusing just on MongoDB. All right, it's a very popular non-relational database that yeah, I like to share it with you. So first of all, we'll need to install MongoDB. So here are a couple of URLs that you should visit, and here's the so if you go to MongoDB, this is the landing page for MongoDB. They have a database solution that is online, which you can use the online version as a service, and that's perfectly fine, especially when you're going to deploy this applications online. And certainly the solution would be to use one of their online solutions. But we want to learn about it a little more hands-on. So we're going to ask you to install MongoDB on your local machines and do some operations so that you'll learn some simple but useful operations on storing, retrieving, creating data in MongoDB. Right. So some of their services are paid for, so we're not going to use that. So instead, Instead, we're going to ask you to head over to their community server. This community server is free. You can download it for your operating system, either Mac OS, Windows, or whatever you have. Download it, and when you download it, it'll create a directory. You can unzip it, and it'll create a directory for you. Now that directory is where we're going to use that directory, right? It includes certain tools in there, which I'm going to go over with you today. Okay, so if you're using a Mac OS, the installer, when you unzip the file, it'll probably create a directory something like this, right? That says MongoDB, Mac OS, yada yada, whatever. And okay, this is Mac OS and Windows. This would be Windows. Now I mean, it doesn't really matter where you unzip it. You can put it anywhere on the file system, but a very common place where these installations should go in a Mac is under user local, right? Now, user local sometimes is protected by password, and so you might need to either use sudo, or it'll ask you to log in into the operating system when you're moving things into that directory, right? So don't be surprised if it asks you to do that. Once you put that directory in there, it will contain in there a bin directory, right? That bin directory has several executable tools that need to be on the path. Okay. Now, on a Mac OS, to put it on the path, you need to configure your bash profile. I'm not sure if you know how to do that. I'm going to have instructions for you in the assignment how to edit your bash profile and export this bin directory so that it adds it to your path. On Windows, your executable will probably end up under program files. And so let me show you here. And so on the Windows side, you'll end up something like this. On the program files, you'll have MongoDB, then will be server 44, and then here's the bin directory. So this bin directory, also on the Mac OS side, you'll have following executables. You have Mongo, you have MongoD, and you have a couple other things that we're not going to use, right? So these two are the ones that we're going to use mostly, Mongo and MongoD. So one of them, MongoD, represents the server, right? And Mongo represents the client application. So very much like in MySQL, right? MySQL, if you remember, we downloaded and installed the community server, and we also installed Workbench, right? So you have the server and you have Workbench. Workbench is the client. It's a user interface client, right, that connects to the server. Okay. So most databases are set up that way. You'll have the server, right, which is responsible for the actual storage of the data, retrieval of data, and executing all commands that manipulate that data. And then you have the client application, which it could be, I mean, there could be any number of client applications, right? Some of you, most of us were using the Workbench client, but some of you were using IntelliJ, the data explorer in IntelliJ, and there's tons of them. There's Toad. There's many other clients out there that allow you to connect to any relational database, right? But we were using Workbench. Here, we're going to be using the server. Here's the server, MongoD. We're going to start the server, and then it's going to start up and start listening at a particular port, which is 27,017 something or other. Very much like MySQL, right? MySQL listens at 3306 or something like that. Yeah. And then we're going to start the client, and it's going to connect to 27,017 and start talking to the server, right? Now, unlike Workbench was a nice user interface, right? Where it lists all the schema on one side, and you can send commands to the server from this graphical user interface. Mongo, the Mongo client is entirely command line interface. Okay, So I'd like you to learn how to use the command line interface. It's a very common way to interact with it. For the MongoDB, the server, it could also be installed. It can be installed as a service, like we did for MySQL, meaning that when your computer boots up, it automatically starts the MySQL server. It's always running, right? MongoDB can also be configured as a service, although we're not going to configure as a service. I mean, you can if you want. I'm not going to have you do that, only because we're only going to use it for this one assignment, for this for the next week and a half or so that you're going to be working with this. So I don't want to install something that that's going to run every time if you're only going to use it for this assignment, right? So instead, what we're going to do is that every time you want to work on the assignment, we're going to have you start the server, right? It's going to boot up, it's going to listen for at 27,000, and then you're going to use Mongo, right, to connect to it to use it, okay? And I'll demonstrate everything today to see how it's set up. So the same thing with Mac OS, right? We're going to have you start the server every time that you're going to work with it, okay? All right, so yeah, let me demonstrate for you. We are going to there's two ways of doing it. One of them asks you to create a global directory at the root of your operating system, right? So you need, the database, the server, the database server needs a location, a file, a directory place where it can store its data. Okay, and so what you could do is one way that you could do it is that you create a single root, a single directory, a global directory at the root of your file system, or really anywhere. It could be in your personal profile directory, right? And then your database, you need to tell it where it is. Now, by default, when the community service starts up, it looks for a directory that is called /data/db in the command line, right? At the root of the operating system. If it's there, then everything's okay. Okay. The problem with this approach is that some operating systems don't like it when you create directories at the root of your file system. Okay. In particular, Mac OS Catalina, and I'm pretty sure also Big Sur, the new one, restrict the access to the root directory. Okay, and so it's not trivial to create a directory off of the root. Okay, with Windows, I believe you can just create a directory off of the root, and that's fine. So I'm not, because it's not standard across multiple operating systems, I'm not going to ask you to do this approach. Okay, so instead, what we're going to do is that we're going to create a directory not off of the root. Notice that this data directory, right? Notice that it's off the root. See that? This is the root right here. Okay, I'm not going to ask you to do that. Instead, what I'm going to ask you to do is create another directory not off of the root. Okay, and then you can tell Mongo, the server, which path to use by applying this flag. You say, okay, so instead of using the default /data/db, use this particular directory instead. Okay, you can override and say, you can override the default and say, use this directory instead. This is the approach that we are going to follow. Okay, let me demonstrate for you. I'm going to start up a PowerShell here. Let me make this. There we go. Oops, clear. Okay, so notice that I'm inside a directory of mine, right, called DB Design in NEU, and in here we have two sections. So let me go into your section. So I'll go CD04, and right now it's empty. There's nothing in here. So we're going to create, and this is explained in the assignment. And we're going to create a directory here where we're going to do our assignment for MongoDB, right? Something like, make a directory called MongoDB assignment. Okay, we're going to go in there, and you're going to do all your work here. Okay, so once we're here, we're going to create a data directory, and that is the directory we're going to tell Mongo, the server, to use, right? Meaning we're going to say, hey, database, store all your content in that directory, right? So we're going to say, make a directory called data. You can call it anything you want, right? But data is a very common name. So there we go. So let's see. Okay, so we have that directory. There it is. Now we can start the server using MongoD, not Mongo, MongoD, D for daemon, and then so this is going to start the server. Notice if I just started this way, right, it's going to fail, right? It failed. Notice that it came back to the console, right, that I can type. Okay, and notice that the reason that it failed, we can take a look at the reason over here, is that it was looking for, let's see if I can find it here. Blah, 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 blah. Okay, there it is. You notice that MongoDB starting, it's assuming that the data path is at C data DB. See that? It didn't find the data DB directory at the root. It didn't find it because I never created it. Okay. And because it didn't find it, it says, well, I don't know where to store my data, right? I mean, you didn't tell me where, so I'm assuming that that's where I need to store it, but I didn't find a directory. Okay. Now, obviously, if you have system administrator privileges and you know how to deal with all that, you can create that directory and just run MongoD all by itself. But instead, just to make our lives easier for everyone, right? I'm going to ask you to instead use just this data directory that we just created under our assignment, right? And the way we're going to do it is using MongoD, and then we're going to use the flag --db path, meaning we are telling you which directory to use, and we're telling you to use our brand new data directory that we created. Okay, if I say enter, right, that this time around, right, it's not going to quit. It's not going to quit. It's forever now listening for incoming requests for data. Okay, notice that the very last few things that it says. Notice that it says that it's listening at port 27017. See that? And it's listening at this address 127.0.0.1, meaning local host. Right? It's listening at the local machine, and it's listening at the default port 27017. Okay. Notice that I can't type. Well, actually, I might be able to type. Well, anyway, it's up and running. Notice that it did not give me a prompt to type anymore. That means that it's up and running. Leave this alone, this terminal, and it's whenever you want to work on your assignment, you're gonna need to restart your server so that you can keep working on your assignment. So leave this this PowerShell alone, and I'm just going to minimize this. So in a separate PowerShell, I'm going to start up a new terminal or console or whatnot, leaving this one running. So let's see, let's run a new PowerShell. Okay, so here's the new PowerShell, and let's make this. Oops, where'd it go? Okay, so let's go into that same directory. Well, it doesn't really need to be in that directory. Actually, it could be anywhere. But let's make sure that we're in the same directory. So let's go to CD, and let's go again into Documents, NEU, DB Design. Let's go into 04, and let's go into Mongo. Okay, there's our data directory. So this is the same directory that we were in before. And we're going to start Mongo here. Why is it not zooming in? Oh, there it is. Okay, I'm zooming in to make it bigger. It's clear. Okay, So now I'm going to start the Mongo client, right? This is the other executable, right? Remember, there's two. There's MongoD and there's Mongo, right? So we're going to start Mongo. So MongoD started the server and it's running on that other terminal. I'm going to leave it alone. Okay, that needs to be running while I connect with this client. Otherwise, it's going to fail. Right. So if I start Mongo, it's going to try and connect to that server, right? And notice that it goes into this command prompt, and this means that it was able to connect to the database, right? If it couldn't connect to the database, this would fail, and it would quit and go back to the to your operating system prompt. Okay, so now we are connected to the database, and we can start communicating and sending commands to the Mongo database server. Okay. All right. Excellent. So we're good. We're connected to the database. Let's start playing around with it. Right. So here's some examples. Right. That the MongoD server is now listening at 27.0.17. Right. And so let's use the Mongo client. So to start the Mongo client, you say Mongo, and as the client starts up and running, connects to the server, and you can start communicating with it. All right, so the first, let's learn just a few basic, very, very basic commands that allows us to interact with the server. One of them is show DBs. Show DBs. Okay, so DBs, show DBs whiteboard. Why? Just a second. Do I have the DB running already? Okay. So it's showing several databases. A few of them are standard that already exist when you install the server, or you might have other databases that you have created yourself. Okay. Now to create a database that we can play around with. Okay. You use the command use, and then the name of the database that you want to use. Okay. Now, for instance, we can create a new database here, and we're going to call it. I'm going to call it whiteboard. Okay, but section 04. Section 04. Okay. Now, notice that it says switch to the database whiteboard 04. So the name whiteboard comes from my contempt against the application Blackboard. So Blackboard is an online learning management system that the university used to use up until last fall, I believe, and then it switched to Canvas. And so you know, a lot of us were not very content with the with the Blackboard software. So, you know, I started building kind of like my own online learning management system in my web dev class. I don't know if you've taken that class. You might have had the chance of playing around with building an online learning management system that we jokingly, you know, as a joke, we call it whiteboard. So anyway, we just created a database called whiteboard 04. And notice that if I ask it to show the databases, right? Notice that it's not listed, even though it says that it's switched over to whiteboard 04. Notice that it's still not listed as my databases, and that's fine. That's actually okay. So it won't actually create the database until you actually store something in that database, which we haven't. We haven't stored anything yet. Okay. So yeah, so let's actually do it. Let's start playing around and storing something in there. So we're going to be playing around with this data model, right? Again, we're going to be using just the regular techniques of creating a data model, representing it as a class diagram. In our case, we have a user class, which is the base class to other classes, faculty and student. And you know, we have faculties can be authoring multiple courses. They can be teaching multiple sections. One course has many sections, and students are enrolled in a whole bunch of sections. So it's the same data model that we've been playing around since the beginning of the semester. And so we want to see how can we implement that data model, but using a non-relational database. Okay. Right. So how do we store data in a non-relational database? Right. So all operations in MongoDB have the following syntax. Right. They all start with db dot. Okay. And then the collection that you want to operate on. Right. So collections is equivalent to tables. Right. So usually in a relational database, we say that tables are the containers of records, of records, rows, right? Here the jargon is slightly different. Instead of tables, we say collections, right? Instead of records, we say documents, right? And so collections don't have records or they don't have rows. Instead they have documents, right? It's just a slight different change in the jargon, but logically they mean the same thing, right? Collection is going to be kind of like a set containing all sorts of data points, just like a table, right? A table has rows or records, which are data points inside of an array or collection or set of multiple data points. Yes. So same thing, just a different name for it. So yeah, so all commands start with db dot, the name of the collection, followed by a command. And the command are, very much like the same standard commands in every database, right? Which are the 4 basic operations, right? You want to be able to create data, you want to be able to retrieve that data, you want to be able to modify existing data or delete existing data, which is in our case, it's implemented by insert, allows you to create data, find allows you to read data that already exists, update allows you to modify data that's already there, and remove allows you to delete data that is stored in there, right? It's the basic 4 CRUD operations that we already are familiar with. So yeah, so that this command would be either insert, find, update, remove, and then you have the data on what it is that you can configure these commands. Let's see, there's a question on the chat. What case does Mongo use? Camel case, Pascal? So it is case sensitive, unlike non-relational databases MySQL. And so all the casing is going to be camel case. The first letter is of the word is underlined. I mean lowercase, right? But then every compound word is capitalized. The first letter is capitalized. Okay. So yeah, so let's take a look at an example. At first, let's take a look at how can we insert data into the database, right? So to insert data, we're going to use the insert command, and with a collection called users, right? So users is the name of the collection. It's kind of like the table. Now we don't have to create a table like we do in a relational database. Right? In a relational database, you first have to create a table. The table needs to have a particular schema, right? That has the fields, the data types, and all that. No such thing here in a non-relational database. There's no such thing as a schema, okay? Which is somewhat cringe. Folks that come from the relational database kind of cringe at this idea that there's no schema, okay? Instead, you say what collection you want to insert in, and you start putting data in there. Okay, to see if you have any collections, right? You can say show collections. So notice that we are in the whiteboard database, and we can list what collections we have in that database, right? We say collections. Notice that it comes back with empty. There are no collections, right? There are no tables whatsoever, and so there's no database and there are no collections, right? Not until we actually store, if we say show DBs, notice that it only shows the ones that are already there. It doesn't show the fact that we are in a brand new database called Whiteboard 04, right? Not until you insert the very first thing. So in this case, we're going to insert our very first piece of information. We're going to insert Ada Lovelace here. We'll say db.insert, right? And then in here, we're going to use the data. Oops, sorry, we have to say where do you want to insert? We're going to insert into users. So db.collection users. and then insert. So insert the data that we're going to store in here is going to be formatted as JSON, right? And why JSON? Well, JSON has become one of the more prominent ways that we transfer data, we exchange data on the internet or any network connection, and also is becoming more and more prevalent the way to store and configure data in any data that you want to store hierarchically. Now, it used to be that data was either proprietary or stored in or represented in the form of XML. At the turn of the century, XML became very, very popular, especially when the folks started to implement web services, and there was a big craze on how to integrate multiple systems using XML. And as applications have evolved and have moved, their preferred way of delivering software has been now the internet and the web, right? More and more these the data exchange between clients and servers has become JSON, and so that's why JSON, we're using JSON here for storing data. And not only here in Mongo, but even in other relational databases such as MySQL, SQL Server, Oracle, they are all embracing JSON as a valid data type. Just like you have fields that are of the type integer and float and varchar and date. Now, in these leading databases, you also have JSON as a data type for a column or a field in a table. Okay. Well, in Mongo, this is the main way that data is stored and formatted as JSON objects. Okay. So anyway, JSON object is basically a curly bracket, and in that curly bracket you can have any number of name value pairs. Right. So for instance, we can have if we want to store Ada, we can have a first name is Ada, and last name is Lovelace. Okay, and we can have a username. It would be A Lovelace. Okay, and maybe the password might be P word, something like that. Okay. All right, so we entered it as JSON string, and notice that when we say enter, it comes back saying, yep, I was able to insert Ada, right? Let's insert one more. If you do an up arrow, you can edit the last command. So let's change, maybe let's insert now Alice. And this is Alice Wonderland. Username is, let's say, just Alice. And we'll leave the same password. Let's insert one more. And maybe this is Bob. And notice that what if I made a mistake and for instance, instead of first name, I use just first. Actually, I already made a mistake. Right? I said first name, right? Let me say first here, and this would be last, maybe. Okay, and so this is Bob Hope, and username Bob. Okay, so I have inserted three folks, and one of the things that you might wonder is that, hey, how come you created 3 records or 3 documents where the schema wasn't exactly the same, right? Notice that this last one, Bob, is using a different field for the first name than the other 2, right? So if we list the content that we just inserted by using the following command, let's say db users dot find. So find, right, is the equivalent as doing a select star from. In this case, we are selecting from users. So we say enter. This returns the 3 documents that we inserted into the users collection, right? If you'll notice, right? It didn't complain with the fact that two records was using first name and the other record was using first. Again, because there is no concept of the schema, right? There is no concept that the data needs to be structured in any way, right? I mean, not that you would actually do something like this where each data point has a different schema, right? More likely, if you have data points that are widely different, right, you'd be using different collections to store different things. Okay, but the point is that there is no validation on that you are storing something that has a specific structure, right? You can change that structure independently whenever you want. You can add new fields, retrieve fields, remove fields, and there is no enforcement that the documents in the same collection need to have the same structure. Okay, so this is a little bit hard to read. So there are several formatters that can transform the data so that it makes it more palatable and easier to read for users. Like, for instance, .pretty. So if you do .pretty, notice that it displays the same content but prettified, right? Made it a little more easier to read. It adds some white spaces, tabs, new lines, right? It lines things up. And again, this transformation, this formatting is only for our eyes, right? It's not that it's changing anything in the data. It's only so that it makes it easier to read for our frontal cortex, right? It's not making any transformation to the data. But at least let's just look at this and start looking at what we have here, right? You'll notice that there's a field here that we didn't create, right? I remember mistyping this, and I entered this data, I entered that data, okay? But I certainly did not enter this data over here. So this data, notice that it starts with an underscore, and it has a specific data type object ID, right? So this here is a field that was created by Mongo itself. I see that it says an underscore. If your field has an underscore, is likely that it was a database. It's a database managed field, okay, and you shouldn't be mucking around with it, okay. Also, you'll notice that the values that it created, they're all unique, right? So we have here 33, 34, 35. And these are indices, right? This is an indexed primary key field, right? That is name underscore ID, and that's a standard name inside of MongoDB, right? And you can use it for fast retrieval of records because it is an indexed field, and you can be guaranteed that these to be unique within that collection. Okay, you can index other fields as well. You can, if you know that the usernames are unique, then certainly you can index a username. Again, if you you would find that the performance are similar. The performance considerations are similar that we found in relational databases, right? If indeed the field that you're indexing is unique, then you can see a huge boost in performance if you index that unique field. If instead you index fields that you don't know if they're unique, right? They might actually have dozens, hundreds, thousands of people that have the same domain or major ID, that they're in the same course or in the same major departments, right? You will notice that the performance boost is not as dramatic as ones that you use for a unique identifier. Okay, so very, very similar to what you might expect in relational databases. So same thing here in non-relational databases. So yeah, we've inserted our first couple of documents, and these documents can contain name value pairs. Now the names are always going to be strings, right, that are used as keys into the objects, right? Like if it were a map. The values can be anything you want, right? They can be strings, they can be numbers, characters, they can be arrays of strings. They could be other objects, right? So your object, your document can contain other objects, right? And those objects can contain other objects, can contain arrays of objects of arrays of objects, right? It could be as complex as you want, right? You can have all sorts of nested information, right? That contains other nested information, right? And so this begs the question as well, how complex should something be, right? So MongoDB suggests that if you can get away with it, right, your objects should be as big as they can, or that it's practical to you for you, as opposed to breaking it up into multiple collections, right? So you can store data either as multiple records or documents in multiple collections that reference each other, right? That you can then join, right, with these foreign key, primary key, and rebuild the structure of the data, or just embed data inside of each other, so that you can improve performance. So if you embed data inside of other data, you can boost performance quite a bit. Let's see, there's a question in the chat. Wouldn't this break normal form? Yes, exactly. That's why I said if you can get away with it. Right? If you can get away with it without breaking normalization, then you should favor creating these nested documents, right? Where you have documents containing other objects, right? If you find yourself that you're doing redundancy, where you're storing, say, a course, you have multiple students that are taking the same course, right? And if you find yourself that you're copying the same content of the course multiple times in multiple students, and that's not a good choice, because you're breaking normalization. But if you have information about the student that it pertains only to the student, maybe you have addresses, right? You have address where that student lives, right? And that's the only address for that student, and that address is not being used by any other student, right? And that address might contain cities and states and zip codes and whatnot, and all sorts of things, and GPS information, right? Instead of having that address live in a separate table, right? Then you can store it instead as a sub object inside of this larger objects. Okay, again, that's why I said, if you can get away with it without breaking normalization, you should favor having nested documents, right? That improves the performance of using MongoDB. The reason is that it is more efficient to go out to the file system once and retrieve as much information as possible, instead of having to go multiple times to the file system to then rebuild a larger structure. So it's better to go out and make the best out of that one access to the file system and retrieve data. Is much more efficient than to do multiple little queries. Same thing when when you're considering when you're doing multiple processes that are communicating over a network, right? They want to minimize the communication over the network, because that is the slowest part of the application, making that network connection from one process to the next. So you want to make sure that those communications are not chatty, and it's not, you want to replace multiple small little connections out from the client to the server, and replace them to being fewer connections, fewer communications, and instead transferring large amounts of data across the network, and then caching that information as much as possible, whoever wants this information, and then process using the processing power of your PC or your operating system to drudge through that data. So you have to consider, obviously, you don't want to break normalization here as well. So the same normalization considerations that apply in relational databases as apply just as much here in non-relational databases. Okay. So those are documents. So these are MongoDB documents, which are JSON objects, and that could be arbitrarily nested and can be arbitrarily complex. Okay. Now a set of these multiple documents make up a collection. So a collection is basically a set of data points or a set of documents. Okay. So now that we have stored some information into the database, now if you go back and do show collections, notice that before it came out empty, right? There were no collections. Now that we have indeed stored something in the database, right? And now it comes back saying that we do indeed have a users collection, right? Same thing with show databases. Before it was not showing our whiteboard 04, and now it is. Now it is showing that we do have a whiteboard 04, which we didn't earlier because now we did insert data in there. Excellent. All right, so now that we know how to store data into a database, let's focus on how can we retrieve that data from the database, right? So we already saw an example where we can say find, right? And .find is, as I mentioned earlier, this is the equivalent as doing a select star from users, right? Also a word on the naming convention. We are going to be using, just like we did in relational databases, we're going to use nouns and we're going to use plural nouns, right, for our collections, just like we did for tables. Yes. The only difference is that if we use compound words here, since Mongo is case sensitive, you can use capitalization to distinguish between two collections, right? So if we want to use compound words, we can use a camel casing, right? Each word, the first letter of each word can be capitalized, right, to distinguish between them. Okay. So yeah, so that's the only difference, but we are going to be using plural nouns. So yeah, so find is just like select star from users. You can provide here as an argument to the find method, you can provide predicates, right? Very much like you have a where clause, right? You can select star from users where, and then after the where clause, you can provide any number of predicates, right? That together are, you can combine them using the and or the or Boolean operators. Here you can provide the predicates as comma separated. So for instance, you might say, find the user whose username, right, is Alice, right? And so notice that it returns that one record, okay? So it does a pattern match, saying that, give me the record or document whose username is equal to Alice, and indeed it finds this one record, okay? You can also retrieve things by their primary key, their primary key being the underscore ID. Okay, and now you have to be careful here. Even though these things look like they're strings, they're not. Okay? So for instance, let's retrieve Bob here. So you can't just use the string here and just paste this. Notice that it doesn't come back with anything. Instead, you need to convert it into the correct data type, which is object ID, right, with a parentheses. Okay, now it does work and it matches correctly to the correct data type. Let's see, there's a question on the chat. Because you made a mistake, would it work if you did first name? Yep, exactly. It certainly would. And so let me just show you. You can say, let's remove this here. And this would be first name. And this would be Bob. Right, and that didn't work. What? What did I call it first? Oh no, I called it first, not first name. So it'd be first, right? First. There we go, Bob. Yeah, each document has its own independent set of properties, right? We have two that use first name, which I misspelled, but for Bob, I use first. And each document is independent from other documents, right? Each document has its own set of properties with its own set of values, and they're not related between them at all. Unlike rows in a table in a relational database, they are related to each other by the schema, right? They all have to match the schema. There's no such thing as a schema in MongoDB, and typically in relational databases in general, right? They will be schemaless, and the schema can change over time, and you can add new fields, you can remove fields, and you can rename them and whatnot. Okay. Okay, so pretty, we already saw the example of pretty, making things a little bit easier to read. We already saw how to retrieve things by their ID or retrieve things by a non-key field like username. Let's keep going. So let's notice that Bob is retrieving all these fields like first, last, username, and password. Okay, so that's the equivalent of using the select statement. If you remember in when we did relational algebra, right, we had a few operators that allowed us to operate on a single table. And if you remember, there was select, right? There were projection, there was rename. There was a whole, there were a few, right? So this example here is the equivalent of the select statement, right? Where you say you select blah 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 from, and then the table that you want to retrieve it from. So this is the equivalent of that. Now find has a second argument. This second argument is the equivalent of the project. So the first argument, right, is the equivalent of the select, where you have a predicate, right? Now the second argument here is the projection. Now if you remember, the difference between select and the projection was that select allowed us to filter vertically and say, well, we have all the records, but I only want a few set of records, and I don't want all the records. I only want the ones that meet my criteria, right? My predicate, right? And projection allowed you to filter horizontally and say, which columns did you want, right? Which fields do you want? So let's take a look at this example here. I can say that by default, we don't use a projection, so it comes back with all the fields, right? All the properties. So it showed me the ID, the first name, last name, username, and password. But here I can list and say I only want the last column, right? And I can say I want the field last, and I want the field username. Okay, I want those two. Right? If I do that, you'll notice that indeed, it's not showing the first field and it's not showing the password. Right? Those were filtered out. Basically applying the projection. Right? But notice that even though I didn't list the ID, and even though I didn't say that specifically that I wanted the ID, notice that it came back anyway. Right? So the ID, by default, even if I don't list it in my projection, right, by default, it comes back anyway, right? It ignores the projection, unless you explicitly say that you don't want the ID. Okay, so for instance, I can go back and say, I can explicitly say I do not want the ID by saying ID:0, right? Don't show me the ID. Right, so notice that now it came back with just the last and the username, but no ID. I could do this backwards. I can say that, I don't want the last name. I don't want the last. That means that it comes back with all the fields except the last. See that? Or again, I can explicitly say that I do not want the ID as well. Okay, there it is. So now I have the first username, the password, but now I don't have the last and I don't have the ID. Make sense? So yeah, so that second argument basically behaves as a projection. All right. All right. So let's keep going. Let's take a look at implementing this data model. In particular, let's implement this section. Notice that section here has a one-to-many between course and section. And if this were a relational database, right, typically what you would do is that you would create a table course and a table section, you would insert a couple of courses in there. You would have a primary key for courses. And then in the section, you would have foreign keys, right? And the foreign keys of the section would be pointing to the primary keys in the course, okay? Now, we can do the same thing here in a non-relational database. Now, the reason you do that in a the reason you do that in a relational database, right, is that there's no nesting in a relational database. The only way that you can establish relationships between records is to have foreign keys, primary keys, right? Where you store some information in one table, some information in the other table, but even though they're related, they're not inside of each other. Instead, you have foreign keys pointing to primary keys on the other records. Here, we could have sections, right? Because they are part of courses, we could say that a course has many sections. So we could implement it as follows. We could say a course has, maybe the name of the course, has a title, when the course starts, blah, 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 blah. But it could have a field called sections, plural, right? That is an array of sections. And then you can have, section instances in there, right? And that would be something legitimate. Yes? The problem with that implementation is that you also have faculties that are related to that section, to those same sections. So how would, now you have the problem that how would faculty be related to the section that are stored inside of the course, right? So that's a problem, right? Because sections don't exist on their own independently, so that faculty could somehow relate to those sections inside of the course, right? So we're not going to follow that implementation. Instead, we're going to implement courses, in their own collection, and we're going to have sections implemented in their own sections, okay, in their own collection, right? And we're going to have them relate, just like we would in a relational database, right? So this is the kind of decisions you have to make, whether you can get away or not of storing data inside of other pieces of information. Only if sections would not make any sense to be stored outside of the course, then we would store sections instead of the course, right? And there's certainly definitely a lot of examples of things that only exist inside something, right? If, for instance, if it's if you have a cascade delete, right, in a relational database where you're doing a composition, that's a good indication that it should be stored inside of the parent, right? Because if you remove the parent, it should cascade to remove also the children, okay? That's a good indicator that it should be stored as a child embedded inside of the course. And we will see examples of that a little later, where you have composition and stored and implemented as embedded objects. Here, notice that we have aggregation. See that? Aggregation. So that means that, I want to hold a reference to you, but there is no cascade. There's no life cycle dependency between me and you, meaning if faculty goes away, not necessarily does the course goes away or the section goes away. So that means that faculty is just going to have a reference to you, right? I'm not going to delete you, if faculty. So that's getting an indicator. That's a good indicator that these should not be embedded. Sections should not be embedded instead of courses, or embedded instead of faculty, and courses should not be embedded instead of faculties either, right? Because you can have multiple faculties teaching multiple courses, even though I'm not the author or whatnot. Okay. Ouch. Sorry, I got a splinter headache that just hit my eye. Okay, so let's start by inserting a couple of documents. Let's focus on sections. Not necessarily we have to create courses, again, because there's no such thing as joining in non-relational databases, right? In relational databases, when we split the data into courses and sections, typically we implement it by having primary keys on the one side and having foreign keys on the many side, right? Where sections would reference courses, and then the way we would rebuild the documents, right? We would join these two by saying that the foreign key in the section is equal to this primary key in the course, and then we would retrieve fields from courses or from sections, right, to rebuild the structure of the data. Here we could do something similar, although we don't have collection, we don't have joins, right? In non-relational databases such as MongoDB, there's no such thing as joins. Okay, if you want to implement those kinds of features, that needs to be implemented separately as part of the application, and we will see how to do that a little later. So anyway, because we don't have the notion of foreign keys, primary keys, and we don't have the notion of relationships, right? Because it's a non-relational database, we can create the sections without the need of a course, but nevertheless, we will use something that looks like a foreign key, but not really. Okay, so for instance, we'll say that these sections, we know that these are sections for these courses. Okay, but it is not maintaining some referential integrity. It's just data for us to know that what sections belong to what course, right? So let's implement. Let's create a couple of sections. Let me copy this, and let me head over here, and let's paste this. Okay, there's one section. Let's insert a couple more. Let's insert now this one. Paste that one, and let's insert this one. Paste that one, and let's do one more. So there we have it. So we've inserted 4 sections. We can see the content that we just inserted by saying db.sections.find. Again, it looks a little bit hard to read, right? So we can append here pretty to make it a little bit more palatable to our frontal cortex. And so we have these 3 or these 4 sections that we just inserted with their own unique identifier. Yes? Okay, now that we have it, these 4 sections, let's just demo interacting with it. For instance, I like to be able to find what sections belong to this particular course, right? So let's do that. Let me copy that, and let's paste that, and there it is. Notice that it comes back with those 2 sections whose course is CS101, right? And it returns that. And now we can specify more predicates, something like comma, and then doing seats. Seats equal 12, right? And so now it's going to come back with only one record or document that meets the criteria, both that the course is CS101 and that the seats is 12. So if you provide multiple matching criteria, it's going to treat this as if it were a logical AND operator, right? Where this is true and this is true as well. Okay, and so it only returns one document here. Now we can be a little bit more explicit by using actual predicates. Let me see how we can do predicates, right? So let's look at this one over here. Let's copy this over here, and let's paste it here, right? So let's take a look at this. So this find, right? It says that we want to match the seats so that they are greater than 30. See that? Right. So this one pattern matched it exactly and said that the seats is equal to exactly 12, right? Whereas this allows us to do range comparison, right? Where the seats is greater than, less than, not equal to, things like that. But notice that all these operators that allow us to do comparisons, they all start with $, and the syntax usually is that you first list the field, just like seats over here, and then the comparison is another JSON object for which the key is the operator, like greater than, and then the value against which you are comparing against, right? If we do an enter, we see that 2 documents meet the criteria where the seats are greater than 30, 34 and 45. Okay. Let's take a look at another one. Here's another one where we are using the AND operator, right? And there's a whole bunch of these operators that allow you to nest together and combine them to implement more and more complex Boolean expressions, right? So let's try this one out. Let's copy this and let's paste it. Okay, and so this one, let's read it, right? So again, it all starts with the opening curly brackets, and this is the closing curly bracket, right? And so the operator is and colon, and then notice that it's an array, right? It's an array of multiple predicates, right? Here's the first predicate, comma, the second predicate. You know, that's why this is an array. Okay, so the first predicate is comparing seats to see if it's greater than 30, and the second predicate is comparing seats, checking to see if it's less than 40, and it finds one document that meets that criteria, which is this one, where the seats is 34, so it's greater than 30 and less than 40. Okay. Now, right. So other than and, right, there's a whole bunch of other Boolean expressions. You can use or, not, and here in greater than, you have less than, not equal, equal, greater than or equal, less than or equal. There's a whole bunch of them that we'll see a little later. There's also functions that allow you to manipulate the results so that they're easier to read. Like, so for instance, this one over here, right? What it's doing is that it's retrieving all the records, but then it's sorting by seats, right? And notice that the seats here are incrementing. Oops. Let's see. Is there a question on the chat? Are there operators part? Are these operators part of JavaScript? No, they're not part of JavaScript. It uses the syntax of JavaScript, right? Of curly brackets and colons and whatnot and arrays. That's JavaScript. But the $ operators, that's MongoDB. They're Mongo specific. Yeah, so notice that the seats are incrementing, right? And going up, or you can do -1 and the now it becomes decrementing. Okay. Also, you can concatenate several of these transformations, like feeding it into pretty. Right, so first there's a sort, and then it prettifies that, makes it easier to read. So both of these don't actually manipulate the data, right? They're only for presentation purposes, right? It sorts it only so that because we want to see it in a particular order, it doesn't actually modify the order whatsoever. And pretty just formats it so that it's easier on our frontal cortex. Okay, so yeah, you can create all these transformations. You can string them together, sort, pretty, right? There's a couple more. Yeah, so these are some of the comparison. They're called query selectors. So equal, not equal, greater than, less than, in, not in. Right, so those are all called query selectors, and these are the ones that we're going to be focusing here in this course. There's many others that we're not going to be covering, but these are the most common ones and you're responsible for, just reading up and understanding their description, and you'll get a chance to play around with them in the assignment. For the logical Boolean expressions, you have and, or, not, nor, right? So your very common Boolean expression modifiers. Also, so yeah, you're responsible for these, which you are asked to play around with them in the assignment. Now you do have other operators that we're not going to ask you to know about, but I encourage you to read up on them and just so that you are aware that they exist. And they are aggregation operators, right? Very much like we did, group by in relational databases. You have also group here as well. You can also do limit, like for pagination, where you can skip the first 10 pages and then limit the results for the next 20 items, right? So you have skip and limit as well. All right, let's look at update. So update allows you to modify documents that already exist, right? So, but you have to be careful, right? So let's look at the syntax. Let's look at the syntax. So here we're going to update a section whose name is 2. Right? So let me copy that and let me paste that. So before we do that, let's look at all the sections, right? Actually, there they are, right? These are the 4 sections we have. We have a section called 4, 3, 2, and 1. So let's modify this one, the section whose name is 2. Right? Oops. Oh, when you do Control C, it quits out of the client. Let's run it again. Let me go in there. Show DBs. I didn't mean to do that. So we're going to use the whiteboard dash 04. Let's do, so I'm going to say show DBs, and let's do a DB dot sections dot find all of them. We're going to pretty them. Okay, there they are. These are all the sections we want. We're going to update a section called name 02. So to do that, we're going to do db dot sections dot update. So update takes 2 arguments. The first argument takes 2 JSON objects. The first one is the filter, right? It's the kind of like the where clause, right? So that you can specify which document that you want to update. So let's update the document whose name, right, is 02, right? Which is this one right here. It's this one right there. What do we want to do? Well, let's say somebody just registered in our section, and so we need to update the seats, right? We want to make them 22, right? So careful, because this looks very, very intuitive, but it's actually wrong, right? Notice what happens if I do an enter. Okay, notice that it says that indeed we were able to match one document and we modified one document. So it looks like it was successful. But notice that if we list all the sections again, notice that something funny happened, right? We still have section name 01, we have section name 03, we have section name 04. Where did section name 02 went? Notice that we have this document here that says that the seats is 22. And yes, we did update a section name 02. We updated the seats to be 22, which looks to be this one. What happened to all the other fields? They're gone. So basically what we did here is that we replaced the contents of that document, which had a name, had seats, right, had the course, right? We blew all that away and we replaced it with this content, right? And that's exactly what happened here. Notice that that document now only has the seats. That's not exactly what we meant to do, right? Instead, what we would try to do is the following. Let's try and do it with this one, name 03. So I'm going to go up again, and let's try to do the same thing with a section whose name is 03. So instead of doing this, right, notice that the seats is 34. Let's say we wanted to change it. Say somebody hated this section, right? And they unregister from the course, they drop the section, right? And now one more seat available, so that's 35. Okay, so instead of doing it this way, what we need to do instead, right, because this is going to replace the document, we don't want to do that. Instead, we're going to put this inside of a set. Okay, so this set operator says modify the following fields. So in this case, we are updating the seats to be 35, right, and then closing the curly bracket over here. We do that. Notice that same thing. It matched one, and we updated one document. If we list the sections again, notice that indeed section 3 is now seats has 35. We were successfully able to change that one field. Okay. Very good. Excellent. So that's that. We can also remove this this over here. Let's demo this. We want to remove it. Now notice that if we try to remove it by the name, that's going to fail. It's going to fail because there is no name anymore, right? So we can't retrieve this by its name. We could retrieve it by its object ID and say remove this one record by its object ID, or we could pattern match it by 22. But careful, let's not make sure that there's no other record whose seats is also 22. Otherwise, we would remove multiple records, right? but we see that this one just matches, it's just 22. So let's remove it just to show how to remove things, right? So let's remove this one right here. And so we're going to say db.sections.remove. And here we can put the predicate by which we want to remove the record. So we're going to say that I want to remove the one whose seats is 22. Right? It says, notice that, yes, we were successfully able to remove one document. And if we look at it, notice that we have 3 sections, and we don't have the section with 22 seats anymore. Okay. So yeah, there's several other commands that I encourage you to read up on. You won't be responsible for all the other ones. You're only responsible for this one, the inserting, the dot insert. All the other ones are kind of like syntactic sugar for the one insert commands, but they might come in handy. For the update, again, there's only really one that you're responsible for. It's this one right here. All the other ones are there for syntactic sugar. And for delete, again, only dot remove you're responsible. All the other ones you're not responsible for. But I still encourage you to read them and become familiar with what you can do with them. Okay. Inheritance and generalization. So if you remember when we worked with the relational databases, we were faced with the same challenge where we had a base class and we had several classes that were inheriting from this base class, and we were asking, scratching our heads, how to implement this in a relational database, because in object orientation, this is a very common data model, right? Where you have one base class and multiple inheritance from that base class. Okay, but relational databases don't support this, right? And well, neither does MongoDB. So we're faced with the same challenge. How do we model this in an object-oriented world? How do we model it in a relational world, and also in the non-relational world, right? Or in particular in MongoDB, how do we do that? Well, we're going to take the same approach that we took in the relational world, right? Where we had three options, right? We said, well, we can use the denormalized implementation, we can use the normalized implementation, or like a combination of the two, right? So we can do the same thing here in Mongo, right? Here is an example on how you would do it using the denormalized strategy. I'm gonna make that bold. Okay. So for instance, if you remember the denormalized strategy, what it did was that it combined all the fields of the child classes and it flattened them and moved them over up to the base class. Okay. So for instance, the faculty might have fields such as the office for the faculty, whether they're tenured or non-tenured, right? Also, the student might have fields such as the GPA, or maybe scholarships for that student and things like that. So what we're going to do is that we're going to flatten this, and all the fields in student and faculty, they're going to move over to the user. And then we're going to have an additional field, right, that I believe in the relational world, we use something like dtype, okay? So here too, we're going to use a field that's going to allow us to determine whether a particular record or document should be treated either as a faculty or treated as a student. So let's do that. So for instance, let's change Ada, right? Let's make her a faculty, right? So what we're going to do is that we're going to update Ada, and we're going to set a typed field of faculty, and we're going to update and give her an office, right? Again, office being one field that is particular or specific to faculty, right? Let's do that. And so for users, db.users.find, and then pretty. Let's see what users we have. So I believe we had Ada. There it is. So let's make her a faculty. So we can say, let's use her username. So we say db.users.update Ada. So that would be whose username is a Lovelace. And the second argument here is our update, right? So we want to set, and we're going to change her type or set her type to be faculty. So this would be faculty. And so notice that set can be used to modify an existing field or even create new fields that that record or document didn't have before. Right? Notice that Ada doesn't have a type. So update can be used for modifying existing columns or properties, or adding brand new ones like type, right? Or even another one like office, right? And so give her an office of 133A or something, right? So let's do, oops, did I spell something? Oh, user's name. I misspelled that. Let me update that. Username. Okay, one match, perfect. Okay, so we do a find. Notice that now there's Ada now has an office and she's a faculty. See that? And we can do the same with another faculty. Let's create another faculty. We'll do, but this time around we're going to insert a random faculty and say db.users.insert, and we'll insert a new document. We'll say that the username is T Lee, for maybe Tim Berners-Lee, and the type is that he is a faculty, and he too has an office, and he's right next to Ada at 132B. Okay, so now we have two faculty. We have Tim Berners-Lee, and we have Ada, and we can now maybe let's make Bob a student, right? We can say db.users.update, and this takes two arguments. The first one is that we want to update Bob, so username Bob, and he's going to be a student. So his type is student. Okay, so now I can discriminate between the two and either choose one or the other. We can say db.users.find all the faculty, so all the ones whose type is faculty, right? Oops, fine. Oh, I missed curly brackets. Right, so I have two faculty, right, which are Ada and Tim Berners-Lee, or I can retrieve all my students. Student, which I just have Tim. Oh, oh no, we updated Bob and just we blew away all the fields. I fell into my own trap. Yeah, well, you get the idea. Generalization. Okay, many-to-many. Okay, so many-to-many is a pretty involved topic. So I don't want to start it now. Let's leave this for Friday when we meet again. Okay. So anyway, what any questions? This is a good stop. Okay, let's see. Is there a question? Is there a rollback for MongoDB? It seems like it's very easy to make. Oh, yeah, same thing, right? We have transactions, we have rollbacks, commit, just the same that is available in MySQL. Yeah. Yeah, there's the same kind of support like in relational databases. Yep. All right, excellent. All right, thank you, everyone. I'm going to make the assignment available later tonight, okay?
Thank you. Have a nice day.
All right. Good night, everyone. Bye. Hola, Mini.